Now, the price of gold has risen above $5,000 an ounce for the very first time, extending a historic rally that saw the price jump by more than 60% last year.
People have treasured gold for thousands of years. All the gold ever mined in history would fit into 3.5 swimming pools. It never rusts or decays, out of its attraction as jewellery, coins and a safe investment in times of trouble and strife.
It's incredible to look at, but it doesn't do anything. Why is it so valuable?
March 1980. Glenn Seaborg, Nobel Prize winner, literal element discoverer, stands in front of a particle accelerator and does something humanity has dreamed about for 2,000 years. He creates gold. Real gold, atomic gold, element 79. The alchemist's impossible dream finally achieved. And then he calculated the cost. 1 gram of his lab-created gold will require more money than has ever existed in human history. We spent centuries trying to turn lead into gold. We finally figured it out, and the moment we succeeded, we proved why we should never, ever do it again. Oh, and there's one more thing the history books don't tell you. The gold we created, it was radioactive. Wear it as a ring and it'll give you cancer before your wedding day. This is the story of humanity's most ironic scientific victory, the radioactive monkey's paw of modern physics. Let's rewind 2 millennia. Alchemists across every civilization obsessed over one question: can we transform cheap metals into gold? They tried everything, heating mercury with sulfur, mixing lead with mysterious elixirs. Even some drank their own concoctions and died horribly. They all failed for the same reason: they were playing the wrong game. See, gold isn't just a shiny yellow metal. It's a very specific arrangement of subatomic particles. Every gold atom has exactly 79 protons in its nucleus, not 78, not 80, exactly 79. Mercury has 80 protons, platinum has 78, lead has 82. They're neighbours on the periodic table, but in atomic terms they're completely different elements. Alchemists were using chemistry, heating, mixing, dissolving, but chemistry only affects the outer electrons of atoms. It's like trying to remodel a house by rearranging the furniture. You're not changing the foundation. To turn one element into another, you need to demolish and rebuild the nucleus itself. That requires nuclear physics, and humans didn't even discover the nucleus until 1911. By the 1930s, physicists realized transmutation was theoretically possible. By the 1940s, we were splitting atoms for bombs. By 1980, Glenn Seaborg decided to finally answer the ancient question: could we create gold? Yes, but at what cost?
I showed this periodic table to some of my friends, the most eminent inorganic chemists in the world, and told them that I plan to publish it, and they said, "Don't do it, Glenn. It's wrong. It will ruin their scientific reputation." Well, I'm fond of saying that I had an advantage. I didn't have any scientific reputation at that time, so I went ahead and published it.
Imagine you want to remodel a house, but your only tool is a wrecking ball launched from a cannon at 99% the speed of light. That's basically how nuclear transmutation works. Seaborg's team started with bismuth, element 83, 4 protons more than gold. The plan? Smash it with high-energy particles until you knock exactly 4 protons out of the nucleus. They loaded bismuth into a particle accelerator, a machine that uses electromagnetic fields to accelerate subatomic particles to absurd speeds. We're talking 99.9% the speed of light. Then they fired. The collision is so violent that protons literally get ejected from the nucleus. 83 protons minus 4 equals 79. Gold. They detected a few atoms, maybe a few dozen, microscopic traces on a detector screen. But here's the part they didn't put in the press release. The gold was radioactive. See, when you violently knock protons out of a nucleus, you don't get to choose which isotope you create. Natural gold is gold 197, 79 protons and 118 neutrons. Perfectly stable. It'll sit in a vault for millions of years without changing. But Seaborg's gold? It was a mix of unstable isotopes. These isotopes decay, emitting radiation. They have half-lives measured in days or hours. You finally have your gold, and it's literally poisonous. It's the radioactive monkey's paw. You got your wish, but you can't touch it. Now, more recent experiments have gotten smarter. Researchers at Japan's Riken Institute used a different approach. Start with platinum-196 and bombard it with neutrons. When platinum absorbs a neutron, it becomes platinum-197. Then, through beta decay, where a neutron transforms into a proton, it becomes gold-197. Stable gold, the real deal. They produced about a few micrograms. That's millionths of a gram. You'd need a microscope to see it. And it cost them millions of dollars in equipment and energy. Let's talk about making something practical. Say, a gold wedding ring. About 5 grams of gold. How much would it cost to create that ring using nuclear transmutation? Scientists estimate that creating 1 gram of gold through particle accelerator transmutation would cost approximately $1 quadrillion. That's $1 quadrillion per gram. Your 5-gram wedding ring? $5 quadrillion. For context, the entire global economy, every dollar earned by every human on Earth in a year, is about $100 trillion. You need to run the entire planet's economy for 50,000 years to afford 1 wedding ring. But it gets worse. Let's talk about the energy. Creating gold requires smashing atoms at near light speed. The electricity needed to run a particle accelerator at that intensity for long enough to produce meaningful amounts of gold is staggering. To create that 5-gram wedding ring, you'd need to consume more electricity than Denmark uses in a year. An entire country's power grid for 1 ring. And here's the cosmic joke. Nature does this for free. Gold is created in the universe's most violent events, when massive stars explode as supernovae, or when neutron stars collide. These catastrophes release more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. A neutron star collision releases about 10 to the power of 46 joules of energy. That's a 1 followed by 46 zeros. It's more than a trillion suns. We're trying to compete with that using an electricity bill. 4.5 billion years ago, these stellar remnants coalesced into Earth. The gold in your jewelry, in your phone, in Fort Knox, it's all recycled stardust from ancient cosmic catastrophes. Nature spent the energy of exploding stars and billions of years to create Earth's gold. We're trying to do it in a lab on a Tuesday afternoon. But here's where this story gets philosophically weird. Why is gold valuable in the first place? It's not the most useful metal. Copper conducts electricity better. Steel is stronger. Aluminium is lighter. But gold has one special property that made it the foundation of human currency for thousands of years. It's really, really hard to get. You have to dig deep into the earth, process tons of ore for tiny amounts of gold, and refine it carefully. It's scarce. It's difficult. That's what makes it valuable. Now, imagine we win the engineering battle. Imagine fusion energy becomes cheap and abundant. Imagine we can run particle accelerators for pennies. Suddenly we can create gold cheaply. What happens to gold's value? It disappears. We're chasing a target that vanishes the moment we hit it. The very act of making gold cheaply would destroy the reason we want it in the first place. It's the ultimate economic paradox. The alchemists wanted to create infinite wealth, but if you can create infinite gold, gold becomes worthless. The philosopher's stone destroys itself. So, why do we keep trying? Why spend millions on experiments that produce microscopic amounts of radioactive gold? Because the real treasure isn't gold. The technology we develop for transmutation experiments has real applications. Medical isotopes for cancer treatment, medical science breakthroughs, fundamental insights into nuclear stability and quantum mechanics. We've created elements that don't exist in nature. Elements 113, 115, 117, 118. We've proven we can manipulate the fundamental building blocks of reality. That knowledge is worth more than gold. Let's zoom out for a moment. There's an asteroid called 16 Psyche that contains more gold than has ever been mined on Earth. Trillions of dollars worth just floating in space. If we develop the technology to mine asteroids, we could crash the gold market overnight. No particle accelerators needed, just rockets and robots. Or maybe, centuries from now, fusion energy becomes so cheap that transmutation becomes economically viable. Maybe our descendants will laugh at the idea that we once valued gold because it was rare. We live in a strange moment in history. We can do what alchemists thought was magic. We can peer inside atoms. We can rearrange protons. We can create gold from bismuth. And it's the most expensive, impractical, beautifully pointless thing we've ever achieved. Glenn Seaborg's microscopic gold sample sits in a museum now. It's worth about $0.0001 in material value. It costs millions to create. But it proved something priceless. We understand the universe well enough to rewrite its rules. We can't compete with supernovae. We can't match the power of colliding neutron stars. But we can understand them. We can recreate their processes, even if just for a few atoms at a time. That's not failure, that's transcendence. So here's a question that's been haunting me. If we could make anything for free, gold, diamonds, platinum, would anything still be valuable? Is value inherent, or is it just scarcity? If we solved every material shortage, what would we chase instead? Drop your answer in the comments. I genuinely want to know what you think. Would a world of infinite material abundance be paradise, or would we just find new things to compete over? If you enjoyed this dive into the cosmic irony of modern alchemy, hit subscribe. We're exploring the beautiful failures and paradoxical victories of human ambition. The engineering challenges that teach us more by being impossible than being solved. We created gold in a lab. It was radioactive, microscopic, and cost more than a small country's GDP. Thanks for watching. I'll see you in the next one.